Welcome to a discussion of synthesis reactions, decomposition reactions, and combustion reactions. In order to understand these new topics, you want to make sure that you're comfortable writing out and balancing a chemical reaction, and that you are familiar with how to identify what an ionic and a covalent compound is. When I think about synthesis and combination reactions, we're essentially starting with some raw materials, like for instance lumber that someone was using to build a house, and we're synthesizing a house. So in chemical terms, we're starting with elements or parts of a more complex structure, and we're building that complex structure, which is a single type of compound. So one type of compound. Sometimes you'll see synthesis and combination reactions, which can be referred to by either label, we're really just talking about the same thing, as chunks of or parts of the compound coming together to form the compound. This might be polyatomic ions or just smaller parts of a complex compound. For clarity's sake, when I am referring to a synthesis or a combination reactions, I will always be referencing this top definition, where we start with elements alone and we build one type of compound. So let's look at an example. Calcium phosphate is synthesized. Write out and balance the chemical reaction. Well, calcium phosphate is my compound, and in a synthesis or combination reaction, I know that that is going to be my product. So here's my product. And so I can set up my chemical reaction by first writing the formula of calcium phosphate, and then thinking about, okay, what are the elements that make up calcium phosphate, and separating each of those out. So I can see there's some calcium, and there's some phosphorus, and there's some oxygen. Next thing I need to do is check and make sure that I've covered anybody who's a silly 7, so any element that would show up as a diatomic when it's by itself. Calcium and phosphorus, we're fine. Oxygen, on the other hand, is going to show up as O2. Phosphorus does have some different forms that it takes when it's by itself, but at this introductory level, we're going to kind of ignore them for the moment. I'm not quite done with writing out and balancing this chemical reaction, though, because I haven't balanced it. So my last step will be to go through and identify, oh, I had 3 calciums and 2 phosphorus and 8 oxygens. And at that point, I'm finished. Decomposition is the opposite of the synthesis combination reaction. In this case, we're starting with a compound and we're breaking it down into its individual elements. So in this question, I've asked you to write out and balance the chemical reaction for the decomposition of copper 2 nitrate. Since this is decomposition, I know that the compound that I'm given in the problem, that this is going to be my reactant. So copper 2 nitrate has a formula of CuNO3 2, and I want to break it up into its individual elements. So I have copper plus nitrogen, that's a silly 7, and oxygen, also a silly 7, and then I have to balance. And I see that I already have 1 copper and 1 copper and 2 nitrogens, and I need 6 oxygens to balance the reaction. Combustion reactions will always follow the general format of something plus oxygen going to produce carbon dioxide plus water. There are lots of different types of combustion reactions, but at this introductory level, this is the only one we're going to discuss. Basically, when you're faced with a combustion reaction, you're really just filling in what the heck is in that box. So when we read the question, it says C3H6 is combusted. That's telling us that C3H6 is filling in my blank spot, and I'm just adding everything else that goes with a combustion reaction. At that point, I need to balance it. And there's a trick to balancing combustion reactions in that you always leave the oxygen till the end. And that comes from the fact that it's easier to balance oxygen at the end because it's by itself. I'm going to look at my carbons first and see that I have 3 carbons on the reactant side but only 1 on the product side, so I'll put a 3 in front of my carbon dioxide. I have 6 hydrogens on the reactant side but only 2 on the product side, so I'll put a 3 there. And at that point my carbons and hydrogens are looking pretty good. When I check out my oxygens though, I see that I have 6 oxygens coming from the carbon dioxide and 3 coming from the water, which is 9 oxygens. I've got 2 in the reactants. The problem that I see here is I have an odd number of oxygens in the products, and in the reactants my oxygens only come as an even amount. So I can't balance this unless I turn that odd number into an even number. And how we do that is we take our reaction and we multiply everything by 2. So I have 2C3H6 plus some number of oxygens, I haven't decided yet, plus goes to 6 CO2s plus 6 H2Os. My carbons and my hydrogens I know are still balanced. What I'm interested in is those oxygens, and I can see on my product side now I have 6 times 2, 12 from my carbon dioxide, plus an additional 6 from the water, which gives me 18 oxygens on the product side. That's an even number. So if I put a 9 as a coefficient in front of the oxygen, I'll have 18 on the reactant side, and my reaction will be balanced. Let's check out another combustion reaction problem. Let's say I have C3OH. Again, we're doing combustion, so I know that I write my C3OH, and then I add oxygen, and I produce carbon dioxide and water. And then I'm going to list my carbons, hydrogens, and oxygens. This one is a little bit different because I have oxygen in 2 places in the reactants. So I just need to keep an eye on that later. My carbon, I have 1 carbon in the reactants and 1 in the products. I have 4 hydrogens in the reactants and only 2 in the products. So I'm going to put a 2 in front of my water. That will give me 4 hydrogens. Oxygens, in the products I have 4, and in the reactants I have 3. Again, I've got an issue here with my even and odd numbers. I'm going to multiply everybody by 2 and see if that problem goes away. I'm going to get rid of those and do that. So that makes my carbons now 2 and 2, and my hydrogens are now 8 and 8. And let's check out those oxygens. I have 8 now on the product side. Currently, I have 2 oxygens from the CH3OH, and I need a total of 8. So I need to pick up 6 more, so my coefficient in front of the O2 becomes a 3, and I end up with 8 O's, and the reaction is balanced. Whoops, didn't plan ahead for the fact I was going to have something over there. We'll just erase this. Lithium nitride is decomposed. In this case, I know that lithium nitride is my reactant because I'm decomposing. Oops, helps if I don't erase again. Lithium nitride is Li3N. Decomposing means I'm breaking it up into its individual elements. Nitrogen is a diatomic, so I need to make sure that I make it N2. I need 2 nitrogens, which means I will need 6 lithiums, and my reaction is balanced.